Noswaith dda a croeso i'r ddarlith heno. Good evening and welcome everyone to this evening's lecture. It's my great pleasure to be able to introduce Professor John Aggleton to you this evening. John was Professor of Cognitive Neuroscience at Cardiff University between 1994 and 2023, and since then has held emeritus status. Quite simply, John is a world expert in the neural basis of memory. His research has widely expanded our understanding of how memory is stored in the brain. Over his long and distinguished career, he has used anatomical, behavioral, and clinical methods to understand how different regions in the brain form connections vital for learning and memory. He has published over 200 scientific papers and won several awards. In 2011, John was made a Fellow of the Learned Society of Wales. And most notably, in 2012, John was made a Fellow of the Royal Society for his work on memory systems in the mammalian brain. In addition, between 2004 and 2006, he was President of the European Brain and Behaviour Society. And between 2015 and 17, he was President of the British Neuroscience Association. All clear markers of the esteem in which he is held. John is also an author, and I can most highly recommend Memory and the Brain, Using, Losing and Improving, that was published earlier this year. It's a book that manages to be both scholarly and totally readable at the same time. I should also mention that the author royalties of the book are going to the charity Brain Tumor Research. John, it's great to have you this evening. Many thanks indeed.
Thank you so much, James. I will get started if you want.
Please do.
Okay. We're all there. Thank you so much, James. It's a very kind introduction. And yes, I have no shame because my last slide will be a plug of that same book. But as James hinted at, there are very good reasons why I'm keen to do so. My entire research has really been devoted to looking at memory, in particular neural systems that support memory. And by memory, in this instance, I'm talking about explicit memory, and that's a term that will become meaningful as I progress. And the focus of today is really to talk about amnesias, which I have studied extensively, mainly in animals, but also in humans. And I'm going to talk not just about real amnesias, but also simulated amnesias. Okay, so let's start with a definition of what I mean by amnesia. And it's quite important to get this term right. Amnesia, as it says here, is a loss of memory for past events, or as we will see, a failure to learn new information so that you forget those events. Critically, in amnesia, other cognitive abilities are preserved, and that includes IQ. So someone with amnesia, you can chat to, they can seem perfectly normal and intact. Some types of amnesia amnesics are prone to a condition called confabulation, where they make up things that they can't remember, and it can be very persuasive. So we're talking about people who are cognitively remarkably intact, with one huge exception, and that is their loss of memory. And in this sense, they're very different to people with dementia, who obviously have a much more global loss of cognition. Now, your understanding of of amnesia may in part depend on books or films that you've seen. According to Wikipedia, there are about 273 films that mainly feature amnesia. So it's a massively popular plot device. I'd like to point out that the way amnesia is portrayed in films is almost without exception completely inaccurate and very, very misleading. And we'll come back to that later. Of the films here, I suspect Memento is the closest to anything resembling the reality of the condition. Okay, now there's a really important distinction to be made right at the offset, and that is between what we'd call retrograde and anterograde amnesia. So retrograde amnesia refers to the inability to remember events before the onset of the amnesia. So imagine some illness brings on this amnesia. Things you can't remember from before then would be called a retrograde amnesia. There's also anterograde amnesia. So this is the inability to learn new information after you have become amnesic. So you can't learn you can't remember people you've met, conversations, etc., etc. And I'll explain a bit more about that. Occasionally, you get somebody who's got a pure retrograde amnesia and no anterograde amnesia, and vice versa. Quite commonly, people will have a bit of a mixture. I'm going to start talking about retrograde amnesia. And I have well, I clearly have no shame because I wouldn't start with take a break. But this magazine caught my eye many years ago. And in fact, it's never stopped telling me some important things about retrograde amnesia. As you can see, this poor lad has woken in hospital, presumably from some concussion or whatever, has seemingly no past memory and has forgotten who his fiancée is, and he, as he beautifully puts it, who the heck is she? Now, you might think this is just a bit of sensationalist journalism, but I can assure you that there is a very nice paper published about two young Italian gentlemen who had car crashes. It's quite separate incidents. Both of them were engaged. Both of them could not remember or claim they couldn't remember anything about their fiancée who came to visit them in hospital. One of them had his fiancée's name tattooed on his arm, so there was no excuse really. But the level of memory loss in retrograde amnesia can be extremely severe. And so it's quite plausible that this bloke couldn't remember his fiancée. Inability to remember past holidays, major events in one's life are quite often forgotten. But at the same time, IQ is preserved. And that means that some aspects of memory are perfectly okay. So semantic memory, your knowledge of things, is fine. And by semantic memory, I mean factual shared information. Cardiff is the capital of Wales. That's a piece of shared factual information. Someone with retrograde amnesia would still remember all those kinds of factual things, the words for things. What they will forget are instances, autobiographical instances from their life. Oh, here we go. The most common cause of retrograde amnesia is head trauma and the concussion that follows. Now, of course, the degree of head trauma that can happen and the extent of concussion varies enormously from the type of incident, of very often a car accident, for example. But the problem the brain has is that it is not fixed within the skull. It moves, and that's to protect it. But unfortunately, when acceleration suddenly stops, the skull stops, but the brain keeps moving, and so it gets damaged. It's not just bruising that occurs, but also there is twisting and breaking of nerve tracts. And the extent of that damage we never really appreciated until the advent of diffusion magnetic imaging that has highlighted this enormous contributory factor to the memory problems caused by concussion or brain damage of this sort. And the critical areas associated with retrograde amnesia are typically the frontal lobe or the temporal lobe. And I'll come back to those in a minute. Now, retrograde amnesia is actually really hard to study. It's hard to study because you want to get a handle on how severe it is. You want to get a handle on how far back in time it goes, because as we'll see in a minute, retrograde amnesia doesn't necessarily mean a loss of memory for everything from the past. It can just mean a loss of memory for more recent events. And so people want to find out what you do and what you don't know. But for retrograde amnesia, this is really difficult because you don't actually know what the person who's suffering from it knew beforehand. So how do you know what they've forgotten? There are rare occasions when we have a perfect knowledge of what to do. So there's an example of an academic called PZ who was very successful and wrote his autobiography. Unfortunately, he was an alcoholic, and he suffered after he's written his autobiography from a form of amnesia called Korsakoff's disease, which is seen typically in alcoholics. And you could test his past autobiographical memory from the items that he'd written in his autobiography. And you could see those that he'd forgotten and those that he still remembered and the pattern of them. But there are standardized autobiographical methods in which you ask people about events from different decades going back, major events, less important events, world events, national events, family events, and so on. You can also ask people about famous faces. And typically what you do is you find a face who's famous for a while and then is less famous. Now, accidentally, given the audience here, I've picked a face that's actually going to be very famous to you all. I could have picked a face from somebody who has won some celebrity singing contest on the television back from 10 years ago, and maybe you wouldn't have recognized it, but I'm sure you recognize this person. But you can also ask people about events from previous years and ask them to tell you who or what they are. And I've just picked four here: Halley Bopp, Costa Concordia, Why We Argued Over a Two-Tone Dress, and Ever Given. And I've given the years for them. So again, you can use these to look back in time and to see when the retrograde memory kicked in and how severe it is. Obviously, the person is Chris Whitty. Just as a reminder, I'm sure you all remember, but Halley Bopp was a comet. Costa Concordia was a cruise ship that came adrift with a loss of life in the Mediterranean. The famous two-tone dress was, of course, one that different people saw in different colours for reasons that are still really hard to explain, it has to be said. And Ever Given was this huge, and I do mean huge, cargo ship that managed to block the entire Suez Canal for days. Now, I've hinted at the fact that past memories may not all be treated alike. And this has been known for a long time. In fact, it goes back to Ribot and his law, Ribot's law, 1881. It's a long time ago. And what he observed is that when people lose old memories, memories before an illness or an accident, there is often a time gradient. And what you see is that newer memories are the most likely ones to be lost. Old memories are more resilient, and so they're likely to be preserved. And you can call this last in, first out, basically. So in the case of someone who has a car crash and brain injury causing retrograde amnesia, what you'll find is that the events leading up to the car crash are the most likely events to be completely forgotten and probably never return. They may return. Events further back in time may well be remembered. The degree and severity of how far back in time people lose their memory depends critically, of course, on where the brain pathology is and how extensive it is. Now, Ribot's law has been such a standard feature and accepted feature of memory loss that people obviously want to explain it, because if you can explain it, it means you understand quite a lot about how memories are retrieved and how some memories are more vulnerable than others. There is what's called the standard consolidation theory, and this is the explanation that you'll find in most standard textbooks. So it has been the predominant theory, and it's really quite straightforward. I'm showing you a picture of Larry Squire because he's one of the main proponents of this theory. And the idea is that sort of personal information, and I've called it episodic, and what I mean is events in your life that you can recall going back in time are held in a brain structure called the hippocampus initially, and without the hippocampus you can't learn these, and we'll see that in anterograde amnesia. So the hippocampus is initially holding all these events in your life, but that information is gradually transferred to the cortex. And as it's gradually transferred, it becomes independent of the hippocampus. And that means two things happen. It means that one, if you have hippocampal damage, you still retain those memories that have been transferred out to the cortex. And because that transfer is in some way far more distributed, it means that they're actually more resilient to pathology. And that means that you should have a pattern of memory loss so that as memories are transferred out into the cortex, they become more resilient. But this happens over time. It's a very attractive hypothesis on the face of it, but there are some problems. One of the problems is that that time it takes for memories to somehow move out into the cortex is very vaguely specified. People will talk about months or years or even decades, and we have no idea why on earth it might take so long for this to happen and what the mechanism really is for that. There are other contenders, and I'm just going to describe one because I think this is probably the main contender. And this is called multiple trace theory, and it's a bit more complicated, but it's really intriguing because it actually builds on a number of fascinating features about how people currently think about memory. It starts with the idea that every time you retrieve a memory, you set up a new representation and set of links. So if we look here at the top left, this is a first event of a memory, okay? So let's say I remember Christmas, and there's a memory I have for Christmas. Now let's imagine I go back now and I try and think about Christmas again. And what I'm going to do is retrieve that memory that I have, but I'm also in the process of doing so, I actually set up new links to do with that memory. And what's also interesting is that because in doing so, it actually makes that memory vulnerable to change and disruption. And that's a whole other story. But the point being that as I repeatedly remember an event, I will set up more traces interlinking the hippocampus and neocortex. At the same time, something else is going on, and that is that as you do this, you create more links in the cortex, bringing that episode together. But the cortical representation doesn't have the same degree of detail. So what you have, you're storing like the gist of what happened. In my case, the gist of Christmas, but not the precise details. And for the precise details, you need the hippocampus. And data to support this comes from things like neuroimaging studies that show that when you ask people to remember old memories, it's still the case that the hippocampus is typically activated, which is not something that would be predicted by the previous hypothesis where those memories become independent of the hippocampus. And it's also argued that those people who have retrograde amnesia, because they have damage to the hippocampus, that what they can do is remember past memories, but in a sort of gist sense. What they can't do is provide the details that the hippocampus can help provide to that memory. I'm now going to talk about anterograde amnesia, but I'll come back to retrograde amnesia in just a minute. So as you remember, anterograde amnesia is this inability to remember new information after the onset of the pathology. And it's most commonly associated with diseases that damage one of two areas, either the temporal lobe, and in particular the medial parts, so by medial I mean closest to the midline, or also structure called the diencephalon, which is a subcortical structure sitting down here in the middle of the brain, which is made up of predominantly of three areas, but it's thalamus and hypothalamus. And there are a number of different diseases that affect these areas that are associated with anterograde amnesia. Lack of oxygen to the brain will cause hippocampal damage. When herpes encephalitis gets into the brain and causes herpes encephalitis, that predominantly attacks the temporal lobe. Korsakoff syndrome, I've already mentioned. This is from alcoholics. That more predominantly hits these diencephalic areas. Tumors or strokes, either in the temporal lobe or in the thalamus, can also cause anterograde amnesia. Now, I've flagged up here that Alzheimer's disease hits these same regions, and this shouldn't really be a surprise in a way. I suspect you all know that one of the earliest symptoms of Alzheimer's disease are memory problems, that People start to fail to remember recent events, can't remember why they went into the kitchen, they can't remember what they did this morning, they can't remember who they spoke to yesterday, and so on. These are all examples of anterograde amnesia. And those areas that, when damaged, cause anterograde amnesia also turn out to be some of those areas that are the most vulnerable and the earliest affected in the progression of the pathology in Alzheimer's disease. So it should come as no surprise that it is a prominent symptom. Now, anterograde amnesia is not it's in itself, of course, it's a tragedy. But of course, neuropsychologists have used that to help tell us a lot about memory and the brain. And I'm just going to run through some of the major discoveries. And here's the first one. And this is the distinction between short-term and long-term memory. And to put it simply, people with anterograde amnesia lose the ability to store new, what we'll call episodic event information in their long-term memory. But their short-term memory is intact. And we shouldn't be surprised by that, because I said earlier that IQ is intact in people with anterograde amnesia and retrograde amnesia. And IQ, to be tested on IQ, to be honest, you've got to have a very well functioning short-term memory. I might also point out that short-term memory is probably one of the most misused terms in psychology by people who don't study psychology. So short-term memory, I'll go to the next slide, refers to a very limited memory capacity that we have. 4 to 5 items, that's about it. And those contents are lost in seconds if they're not refreshed. So when people talk about short-term memory for things, oh, I've got a terrible short-term memory, I can't remember what I did this morning, or I can't remember what I did yesterday, or I can't remember stuff like that, that's not short-term memory. And if you go to the internet, you'll find countless mistakes of this sort where people talk about short-term memory and it's not short-term memory. So anyway, short-term memory. So it's this very brief memory store, but without it, we couldn't follow a conversation, we couldn't put together, I couldn't do what I'm doing now, for example. And the really interesting thing is that we've known for a long time that people with anterograde amnesia have this preserved component that they are able to show short-term memory. So this is when people are asked to freely recall a list of words, and what you see is that the last few items that they hear are most likely to be recalled. This effect is called recency, in fact, and severe amnesics will show seemingly almost normal recency, but their ability to remember the events that are further back in time, and are therefore thought to be in long-term memory, is very poor, as you would expect. So you have this preservation of short-term memory. And that's been one of the key reasons for believing that short-term memory and long-term memory really are distinct components of our memory systems. Not they can't talk to each other, they most definitely have to. It's just that they have different neural bases. Now, I'm now going to talk about how amnesia has told us about different types of long-term memory. So I've moved from short-term memory to just long-term memory. And this gives me an excuse to show a photograph of, I'm not 100% sure, but if he's not my ultimate all-star sports person, he's blooming close. And that, of course, is Mark Cavendish. Anyway, and there's a very good reason I'm showing Mark Cavendish, by the way. It's not just an excuse. Well, it is, but there's a good reason. I've mentioned short-term memory versus long-term memory, but now I'm going to tell you about another distinction, and that's between explicit memory and implicit memory. When we talk about memory, we almost always think we're talking about memory that we can consciously recall and describe. That's how we think about memory normally, and that is explicit memory. So my memory for what I was doing this afternoon, for the fact that I went for a walk around a reservoir this morning, the fact that I would have gone for a cycle yesterday and I can describe my cycle, those are all explicit memories that I can describe and tell you. I have insight into them. But we have a host of memories. These are things we've learned, so they are memories that we use, but we aren't actually able to consciously delve into what it is we have learned. Examples of things like perceptual and motor skills and classical conditioning. So cycling a bike is a perfect example. The ability to stay upright on a bike involves all sorts of skilled perceptual motor learning. It's implicit memory. And the reason I can tell you that is because I cannot, nor can anybody tell you actually how you stay up on a bike. If you try and teach a child how to ride a bike, all you can do is just tell them to pedal, and eventually they'll get it. You can't tell them exactly what it is they have to learn and remember to do, because we can't do that. What we can do is use explicit memory to tell us about the last cycle ride. That's a different matter altogether. So we have this distinction. And the reason I'm telling you all this, of course, is that in amnesia, this distinction is observed. So explicit memories are lost, implicit memory is completely preserved. And there's some famous examples. This is from an amnesic called HM. He's probably the most famous neuropsychological case, single case there's ever been. And he was severely amnesic, unable to learn all sorts of explicit things, couldn't remember conversations, couldn't remember who he'd just seen, and so on and so forth. But what he was able to do was learn new perceptual motor skills. This is a particularly tricky task. You have to draw the outline of a star, but you can't see your hand directly. You can only see it in the mirror. And you learn to correct what you can see, and so you've got two competing sets of feedback, what you can see and what you can sense, and you have to get those to come together. And you get better and better at drawing this star. And you can see HM's performance here. And of course, he maintains it over days. So he's able to learn a new skill, even though he can't remember explicit information. Here's another perceptual skill that amnesics are perfectly good at learning. So if I show you a set of words that are mirror imaged, in this case, I've deliberately picked slightly obscure words, with a bit of focus, you can work out and read the words. If I kept doing this to you, you would get better and better and quicker at reading words that are presented in this mirror imaged form. And that's a form of learning. It's a perceptual motor skill. But again, you cannot tell me what it is you've learned. You can tell me the words, but you can't tell me how you learnt to read the mirror image quicker than you could before. And people with amnesia show completely normal learning on this task. So what we find is that anterograde amnesia affects long-term memory. So the ability to learn new information that was in long-term memory, it spares short-term memory, but that actually it only affects some aspects of long-term memory. And we can divide long-term memory, as I said, into implicit and explicit. So it's only explicit long-term memory that's affected. And we can go further than that what it really affects is our ability to learn about new events in our lives. And this is called episodic memory. Factual information, semantic information is more preserved. And some factual information, new factual information, can often be learned, whilst events cannot be. Okay, I'm going to talk about KC because he captures quite a lot of the ideas I've just been talking about. So, tragically for KC, he had a terrible motor accident on a motorbike when he was age 30. And you can see, you don't have to be a radiologist to see that he suffered quite a lot of brain injury. So this is the temporal lobe here. This is the medial part of the temporal lobe, and the hippocampus would be here, and it would be here. And you can see that there is a big hole here. So he's got bilateral damage, extensive bilateral damage to his hippocampus. His cortex looks pretty good. Now we're cutting the brain in a different plane. This is the third ventricle, and this is the very front of the thalamus, so it's part of the thalamus. And here he's got thalamic damage as well, just to add to his problems. He recovered from his motorbike accident, but he suffers, it still does because it's permanent, an incredibly dense retrograde and anterograde amnesia. So he can't remember past events and he can't learn new past events. So he has this extremely dense loss of episodic memory, but he can retain many skills and semantic facts that he had prior to the injury. So there's this stark contrast of what he has lost and what he's retained. His general knowledge of the world is preserved. So in a funny sort of way, it seems as though he can function through life, but he really can't, because he cannot recollect personal experiences from the past. And as you'll see, it also affects the future. So here is a photograph of Casey's family. This is from his brother's wedding. Casey is here on the right. As it says in the caption, he can recognize the individuals, but he has no idea what the event is, and rather charmingly, he has no idea why he has curly hair. But he could remember how to do all sorts of sort of semantic factual tasks, how to change a tire, how to play chess, certain autobiographical facts, the schools he had attended. But he couldn't remember games of chess. He couldn't remember a very dramatic event, which was crashing a dune buggy. He knew his brother was dead, but he couldn't remember the circumstances around it. So he has this extraordinary loss of past autobiographical events, but facts are still retained. So again, comes back to this distinction within long-term memory of factual information and episodic information. And as I said, he lives in the present, and we'll come back to that in a minute. And you can see this contrast between factual information and episodic information in KC. His accident was in the 1980s, and this is a contrast between factual information he could recall from photographs, family photographs, going back over the decades. You can see it here, and he's doing very well. There's a blip, he's not perfect, but nevertheless, he's doing remarkably well. And he's actually learning some new ones after the accident. However, his memory of individual events is truly terrible in the past, and subsequent to his accident, it's actually complete rock bottom. He really is remembering nothing at all. It's very tragic. So we have this contrast that amnesics tell us about within our memory. So long-term memory is not just one thing. It's actually made up of different components. And we know that implicit memory, these kinds of learning, rely on different neural substrates. And that means that, for example, they're far more resilient to certain diseases, including Alzheimer's disease, for example. So implicit memory, new implicit memories are far more resilient. They are eventually lost, but to begin with, they're far more resilient. And with anterograde amnesia, you have this split between events and facts, episodic memory being the vulnerable form, again, telling you that there's something different going on. I'm just going to briefly allude to something that the study of amnesics has also told us, and that's really revolutionized the way we think about memory and what memory is for. I should have put this quote up, actually. There's a great quote from a Terry Pratchett book. If you ever read Discworld books, and if, you know, I'm afraid I'm a sucker for them, but it's this great quote he wrote about 20 years ago saying that people think of memory as being a trail of a comet. So it's always behind you. But actually, memories go forward. And psychologists have only just caught up with this, really. This is a concept of future thinking or future memories or future episodic thinking. It comes in, there's different lots of terms for the thing. And the reason people have cottoned on to this are two main pieces of evidence. One is that if you put people into a brain scanner and you look at what happens when you ask them to remember events from the past, and you ask them to think about, to simulate future events, to simulate them, imagine them, overlapping brain activity occurs. The same neural machinery is switched on that you need for remembering the past and to imagine the future. And that's what you see in dense amnesic. So KC is a case in point. So he had no personal past, but he also couldn't imagine the future. And so he's lived in the present. It's a very weird concept to think about. Let me show you. This is from a study published in 2007 by Demis Hassabis. You might recognize the name. He got the Nobel Prize a year ago for his work in AI. At that time, he was a neuropsychologist. And he was working at this time being supervised by the wonderful and great Ellen Maguire. And I would have mentioned her anyway, but she gets special mention because very tragically she died just a few weeks ago. And the whole world of neuropsychology is in shock. Anyway, what they did was study a group of amnesics with bilateral hippocampal damage. And they simply asked them to imagine events that haven't happened. These are future events. And I just got two examples here. Imagine you're lying on a white sandy beach in a beautiful tropical bay. P stands for patient, and con obviously is a control. Look at what the patient does. So the patient understands the question. They know exactly what a tropical bay is, and they describe sort of factual components that would go with there. Seagulls and the sea, and there should be sand, and they actually hear a ship. And that everything is blue. But really, that's about it. What they cannot do is describe, make up details about how that might be and what actually might be present and how they may affect each other or interact with each other. That's because they can't imagine these future experiences. It's very different for the control. I won't read the whole thing out, but if you glance at it, you'll see quite quickly that there's a lot of description about how it looks, how different buildings relate to each other, the geography of the place, what's going on, even though this is all made up. So we have this situation where people with the hippocampus can't remember the past, but they also can't imagine the future. I say this has been a revolution in how people think about memory because what it's telling them is that memory may be very important, or even more important, for simulating future events than it is for the past, even though it isn't naturally how we think about it. So, antegrade amnesia has helped us tell us about short-term memory versus long-term memory, explicit versus implicit forms of memory, and the fact that because the memory loss is selective, in other words, it affects memory but not other aspects of cognition, then we have a great insight into brain structures that might be critical for the formation, the consolidation, or retrieval of memory. And it has helped this revolution in how we think about memory, that it is as much for the future as it is for the past. I'm going to finish this section with just a couple of types of amnesia that you may have heard of or not, but they're unusual and they're rare, but they are fascinating. Transient global amnesia happens typically physical, but sometimes emotional stress. It's a rare thing, happens to somebody, and it probably will never happen again in their lifetime. There's a wonderful description of it by a journalist called Trip Gabriel, called The Day That Went Missing. And that just about sums it up. So what happens is that suddenly in the course of a day, the person finds that they simply do not know how they got there, now where they are, and they have to ask all sorts of questions about why am I here? What time is it? How did I get here? He couldn't remember where he'd parked the car. However, he was still able to complete a couple of races. So his ability, his sort of perceptual motor skills were intact, but he couldn't recall what he had done. His wife had to come and take him to the hospital, and he had a scan, and over the next day, his ability to remember what's happening recovered, but that day was lost. So the actual day of the transient global amnesia, he could not remember the events therein. It had gone. And that's transient global amnesia. It's a very rare but fascinating condition. We don't know much about it because it is so rare. because it's transient. We assume that it's caused by cardiovascular changes, and most people assume it's something to do with blood perfusion changes to the hippocampus. But to be honest, we really don't know. There's other types of amnesias that are fascinating but perplexing, and these are psychogenic amnesias. So this is where you have a loss of personal memory, but there's no evidence of brain damage. Or in some psychogenic amnesias, the memory loss is far greater than the pathology. So it looks as though there's some additional process that we just don't understand that's adding to the memory loss. A term that you may have heard that's a sort of famous type of psychogenic amnesia is a fugue. It's sometimes called a dissociative amnesia. And what you have is somebody who shows a loss of personal identity, so they seemingly don't know who they are, they can't remember their life history. They, as a consequence, will often wander around, but unlike transient global amnesia, they don't show that repetitive questioning of where am I and why am I here and what's been going on. They kind of drift through time, even though they don't seem to know what was going on in the past. They can still operate and still function, which adds to the curiosity of fugue. It's often precipitated by stress, and somebody who, and we do not know for sure, never will, probably suffered from a fugue is a certain Mrs. Christie, who disappeared for 11 days in 1926. The famous Mrs. Christie is, of course, Agatha Christie. She had just discovered that her husband was having an affair and was planning on leaving her, and she set off in a car, had a crash, and then disappeared. And was finally found in a hotel in Harrogate 11 days later. There are all sorts of extraordinary things about her disappearance. The newspapers weren't very kind and thought that this was some kind of deliberate ploy, being well known as such an inventor of fantastic ploys in her books. But in fact, if you read the details, it really sounds like she suffered from a fugue. There are a variety of psychogenic amnesias that are graded by this, as I said, the extent of the memory loss and the contribution of possible brain dysfunction. So fugue is the one where you've got apparently no overt brain dysfunction. They are almost always associated with psychological stress, but it's worth pointing out that psychological stress is not guaranteed to cause amnesia, even in the severest situations. And we know this because there are some extraordinary studies of survivors from concentration camps from World War II, people who were debriefed at the time and then seen decades later and asked again about their memories. In a few cases, there's evidence of islands of memory that we would expect to be there but have been lost, but vast amounts of memory is often intact. In other words, they don't show a psychogenic amnesia, even though if you're going to pick a group of people who most likely would, they would. I mention 51st dates here because it just highlights how difficult it can be to sort out psychogenic amnesias. If you've ever seen the film 51st Dates, you'll know that Drew Barrymore suffers from an extraordinary condition, which is called Goldfield syndrome, in which the events of each day are forgotten overnight. So she starts each day as if she can't remember what happened the day before. It's a great plot device, but Goldfield syndrome does not exist. And that's how all neuropsychologists thought about it. However, in 2010, a patient, FL, suffered a car crash and had an array of symptoms that look alarmingly similar to Goldfield syndrome. In trying to make sense of this, the neuropsychologists decided that it was a combination of a real psychogenic amnesia, but also a degree of simulated fate amnesia, partly brought on by her knowledge of 51st Dates. And I say this because it just highlights what a difficult territory you're in when you're trying to separate out real from simulated amnesias. And that brings me neatly on to this last category of what I'm going to talk about, and that is about simulated amnesias. And there are two main groups of people who are likely to deliberately do so. You've got criminals and you've got feigned injuries, in particular for insurance claims. Let's start with criminals. So there's a survey from 1994 about people who've been imprisoned for life. So they're in for very serious crime. And a third of them claim no memory of the crime. Now, there might be good reasons for that. They might have an alcoholic blackout, otherwise they might have been so drunk at the time, they subsequently can't remember what they did. It's an alcoholic blackout. They may have had, it may have been a violent crime and they received a head injury, in which case they might have a retrograde, well, have amnesia for it. Of course, they might have been taking drugs that can mess up your memory, or they also could have suffered extreme stress-induced amnesia, which is sometimes called a redout, which to distinguish it from a blackout. However, this is not easy territory. It's complicated because memory loss has some gains for the criminal. In other words, saying that you can't remember. It avoids implicating others. It may lead to neurological tests that could help your defense. So in other words, if it uncovers some previous neurological condition that you didn't know about or some evidence of pathology, it may allow you to claim some degree of diminished responsibility. And at the same time, we know for sure that faking does occur. Now, right at the top here, I've said that memory loss is not a defense, except in the case of what's called automatism. Now, an automatism is something where you cannot help yourself from the action that you do. For example, if you have epilepsy, it might cause an action and you cannot stop it. There is a proviso here, and that is unless it's knowingly self-induced. So if you deliberately don't take medication that you know will stop you having a particular symptom, and that symptom may be sufficient to cause the death of others, then it is not an excuse. Now, this is, of course, if you think for 1 second, this is a very topical issue because it has suddenly been raised in the whole issue of Valdo Calacane and the murders in Nottingham in regard to his deliberate not taking of his antipsychotic medicine. And I have no idea how this will play out, but it's something we should pause for thought about because, of course, he was prosecuted for manslaughter, not murder. Anyway, faking does occur, and it certainly occurs in insurance claims. We have this post-concussion syndrome in Britain, and estimates, it's extraordinary, that about 40% of those receiving evaluations for a mild head injury from concussion may be feigning some symptoms. I say some, it doesn't mean they're feigning all symptoms, but they're feigning some. And a cynic might notice that countries where litigation based on post-concussion syndrome has been abolished, well, guess what? The condition has largely been cured. So there is a lot of faking going on. And you can see why. I mean, it's very easy to fake it, and it comes with rewards. So how do you detect someone who is faking their amnesia? So brain scans, including MRI, of course, would be very helpful because they would tell you if someone has an obvious pathology. But in the case of a psychogenic amnesia, this might not be the case. In other words, they still might not have structural changes, but they still actually could have an amnesia, such as in the case of a fugue. You could look to see if actually they are simulating because they are lying. Now, we know from functional MRI that lying is more effortful, and certain parts of the brain, such as prefrontal cortex, tend to be more active in people who are deliberately lying. But this difference is quite subtle, and you can show it when you compare groups of liars against groups of people telling the truth. but it's not strong enough and reliable enough for individual cases. Doesn't stop enterprising people jumping on the bandwagon. So as early as 2006, companies started offering fMRI tests for insurance fraud. It probably acts as a quite good scare for people who might consider submitting a fraud. I've got no idea how often or not this is used. As a psychologist, I'm kind of more interested in cognitive tests of how you distinguish real amnesia from people simulating it. And it comes about from people who faking amnesia, not really understanding the nature of amnesia. In other words, they've watched a lot of films about amnesia, but not many textbooks. They tend, very commonly, to exaggerate their memory loss, so that they'll show memory loss for semantic information of a sort that would be most unusual. They don't appreciate the type of sparing that occurs within amnesia. So they don't appreciate sparing of implicit memory, so you can train people up on new implicit learning tasks. And of course, these people will pretend that they haven't learned them and willingly not display that learning because they think an amnesic couldn't. They also don't appreciate that short-term memory is spared. And so what you do is you come up with a task which is basically a short-term memory task, but you dress it up in a way to make it look a bit more demanding, even though it's still a short-term memory task. And here's one, for example, the coin in hand task. You simply show a coin to somebody, it's in your hand, you close your hand, you ask the person to sort of close their eyes and count back from 10, and then point to the hand with the coin. This is an incredibly easy task. It's 50% chance you're getting it right. And people with amnesia are very good at it because it's well within their short-term memory range. People who are simulating amnesia can't resist overdoing it and will make far more errors than would be normal. The same logic applies, to this popular test of faking memory. And it's based on forced choice recognition, I can barely say it. Imagine I show you a picture like this, and I ask you to remember it, and I show you another picture, and I ask you to remember that, and I show you a whole load of pictures. Let's show you 50 pictures. And at the end of showing these single pictures, I then show you pairs of pictures, and I ask you to point to the one that I showed you earlier. So it's clearly a test of memory. And in this case, you'd point to this one, and then you'd point to this one. So it's forced choice recognition. You have a forced choice between a novel and a familiar, and chance is 50%. People with amnesia, people faking amnesia, can't resist making sure that they do really badly. And that means doing worse than 50%. People with very severe amnesia will get down to 50%, but they won't get below it. People faking it very often can't resist going down below 50%. And if you see that, you can be pretty sure that you should be very concerned, that it should ring alarm bells that this might be somebody faking amnesia. So I'm going to stop there. I'm delighted to answer questions about anything I've covered about amnesia or really any other related aspects of memory. As James very kindly pointed out, I've just published a book which covers material I'm talking about, but obviously a lot of other material all about memory. It would cost you, I think currently it's like £22 from Amazon. Dare I mention Amazon? And as James very kindly pointed out, all my royalties are going to brain tumor research. So it's a win-win. I hope. I hope you'll think that. Anyway, I'll stop at that point and gladly answer questions. Let me just come out of this. Right, James, do you want me to completely close my screen?
No, that's fine, John. Many thanks indeed. That was absolutely fascinating. I'm sure it's provoked a lot of thought and questions in our audience this evening. And I'd encourage them to start placing their questions into the Q&A option. That button is available at the bottom of their screens this evening. And whilst we're waiting for those questions to come in, John, perhaps I could
Yeah.
just ask you a couple of things. What about the importance of sleep in all this, John, in terms of memory? Could you give us a comment on that? How valuable?
Yeah, I'd be delighted to. Okay, so sleep, yeah, sleep is an enigma. Um, we know that if you don't have sufficient sleep, you are poor at learning new things. We also know that if you don't have sufficient sleep, it affects your remembrance of recent past events. So there's unquestionably a link between sleep and memory. Um, there has been a huge amount of study into this. It's actually very difficult because what you want to do is deprive people of sleep and see or aspects of sleep and see it affects memory. But of course, that makes them more tired, and so you have to somehow control against arousal effects. But in recent years, people have become more and more convinced that sleep has an important role, in particular in the consolidation of memories. So what has taken place in previous few days is in some way consolidated, or consolidation is aided overnight. And both non-REM sleep and REM sleep contribute together, but also in slightly different ways to this process. Most models argue that in some way they are aiding this interlink between the hippocampus and the cortex and setting up more robust, I use the word engrams, memory traces in the cortex. Now, the details of how that is achieved is still very vague. And there are all sorts of curiosities to do with sleep and memory. So, for example, you might suppose that those animals that take very little sleep have poor memories and vice versa. But of course, if you look at the animal kingdom, it doesn't work like that at all. So that there's remarkably little relationship between the amount of sleep and the kind of cognitive demands that are put on those animals. And that's because there are other huge pressures on how long we sleep. There are lots of natural selection pressures that mean that some animals simply daren't sleep for long and others can. And if that's the case, you wonder what the primary reason for sleep is, and that means is memory consolidation a sort of subcomponent rather than a really important component. So that's where a lot of the debate hangs. But people are increasingly convinced that it is important, and people are equally convinced that good sleep, and there is a thing called good sleep, is helpful for cognitive status in general, including memory.
Great. And I think that hopefully addresses the question that has come in about lack of sleep affecting studying there. I think you've
Yeah, it really does. I'm not the world's best sleeper, and as people get older, it often becomes harder and harder to sleep. When it comes to studying, and in particular students, there's an interesting problem, and that is that your diurnal rhythm in adolescence is pushed back so that you want to go to sleep later, but you want to get up later, and that's quite natural. That's not laziness, it's quite natural. And the problem is that schools, for example, aren't geared to that. They want you to get up at 7 o'clock when your body at that age wants to sleep on, and that does not help you academically.
sure. A few related questions,
Sure.
John. Do you see it ever possible to use the understanding of amnesia to help to reduce the problem for patients? And a related question, will there ever be a cure for amnesia?
That's a really good question. Sorry, that's a very trite thing to say. That's a really good question, but it is. Some amnesias tragically are permanent, and they show absolutely no sign of recovery. Now, that said, because people with amnesia, let's say you've got anterograde amnesia, you can't learn new events, episodes in your life, you still have a rich store of past memories and all these skills that you have. I mean, I wouldn't recommend going out and driving a car. Well, you really should not do so. But in theory, you could drive a car. You wouldn't do so. So how do you best help people like that? What you need to do is really help them by prompting them. And there's all sorts of ways of doing that. You can have electronic prompts that are on your phone because you can remember to use them. You could have paper prompts that are written up around you. Some people with amnesia have insight into their memory problems. So they are the people who are most appropriate for kind of rehabilitation techniques. Some people with amnesia actually have no insight into their memory problems. And this is particularly true in things like conditions like Korsakoff syndrome. So they have this incredibly severe memory loss, but they do not appreciate that they have it. So they are almost impossible to really assist. As I said, some amnesias are not permanent though. Quite a few retrograde amnesias caused by concussion, so this is memory of past events, will bit by time recover. And there's actually a kind of quite common progression rate as to the kind of things that come back in time. The nature of the sort of what, where, and when kind of information. We don't have drugs to help people recover from amnesia. I'm afraid the only instance of that are people who've acquired amnesia because of, for example, vitamin deficiency, which is what happens in Korsakoff syndrome. And the very first thing people do is I put on multivitamin, but in particular certain kinds of vitamins that they are depleted in, and that can help the situation acutely, and some people do okay. If, however, that doesn't help them, then they are in trouble. I could go on for a long time about this question. I don't know how long you want me to
So
answer
yeah,
for.
we've got lots of other great questions coming in. So
I'll,
you
I'll
will
stop for the moment, but rehabilitation is difficult if one believes that the loss is pretty permanent. That's the sad truth.
yeah.
But not all amnesias are permanent, I must add.
Okay. Thanks, John. Um, what factors would you say contribute to brain fog? Is it similar to amnesia? This is obviously quite a topical one with maybe long COVID, post-COVID.
Yes, yes, yes. So I was involved in a very large study looking at COVID, and we wondered, not so these were people hospitalized, so these were people who had severe cases, and in particular, we're looking at cognitive changes and memory in particular. And what came out quite clearly was that obviously there were cognitive changes, and these would last months. We haven't been able to follow up for years, but it was not the case that memory was particularly affected over and above other cognitive aspects. So it's not especially vulnerable, for example, in long COVID, but it's part of a broader package of cognitive issues. Um, the, People talk about brain fog in lots of different contexts. So it's difficult. I mean, for example, people talk about multitasking a lot and make claims about whether they're good or bad at multitasking. The brutal truth is that multitasking invariably makes you poor at one of the things you're trying to do. And of course, multitasking is a plague of modern life with, mobile phones to hand or people revising with televisions on and such like. Now, it's not brain fog, but what you're doing in a way is setting up a scenario that as soon as you're dealing with difficult material, might as well be a brain fog because you will cause problems. It's fine if you're doing easy tasks, easy cognitive tasks, but as soon as they get demanding, it becomes really hard. Um, I mean, there's also issues to do with different types of drugs, obviously alcohol, I could talk about, et cetera, et cetera.
John, on a neural level, how does the active suppression of a memory result in it being completely or very nearly forgotten?
Oh, I'll have to say that again. That's a great question. So, um, people, if we go back a few decades, people would talk about Freud's ideas of repression. So he thought that in our early lives, terrible things happened to us. Well, not terrible things, but we thought they were terrible. And so we repressed them. We had some mechanism that somehow blocked out all these emotional memories. And that's why one of the reasons why we can't remember so many things from from our early first few years. It's not due to repression, or Freud's version of repression. It's due to a variety of factors, and I'm more than happy to talk about that, if someone wants to know. So far, so good. And then about 15 years ago, a researcher called Michael Anderson started asking a very simple question. What happens if you ask people to actually forget a word? So in other words, he'd give people lists of words to remember, and after some of them, he'd say, I want you to forget this word. Even though they've just been told to learn them, I want you to forget it. You have to do all sorts of very clever controls to make sure that the effect you're looking at is the right one. But what it clearly demonstrated is that people really can forget things they want to forget. I'm quite good at forgetting the football exploits of my team, Tottenham Hotspur, who are playing tonight, and I just have dread about that. So the reality is we can do so. The neural mechanism that is involved in this kind of active directed forgetting, we now know something about. And it turns out that we use what are called executive processes, predominantly in prefrontal cortex. And what they do is they act upon, and we come back to the hippocampus yet again, but back upon the hippocampus, and in some way they act to inhibit the way the hippocampus would naturally store, for the time being, those memories. And its effect is fascinating because not only does it suppress those memories, but it also causes a kind of shadow. So things immediately adjacent to the things you're trying to forget, you also forget. So we now have a mechanism for this. The only thing the missing part of the jigsaw is that in experimental situations, that degree of forgetting is not huge. So what we can't do is demonstrate that that mechanism is sufficient to cause the huge memory loss that can occur with traumas. And we think that's due to a different set of mechanisms, probably induced by stress hormones, glucocorticoids. But the mechanism of that is unclear. And one of the reasons it's unclear is because we also know that the release of stress hormones can improve memory. So we have this rather complicated scenario that what a mechanism that can somehow improve memory is also giving us a complete loss of memory. And we don't know how to put those two together.
Okay. I think we've sort of addressed the related question there. Is there a way to induce partial amnesia to forget a traumatic event? I think you've kind of...
Well, it's not good enough to just say, I want to forget it, because if it's a traumatic event that is persisting in your mind and you tend to ruminate over it, you're not going to lose it that way. We do know that there are certain neurotransmitters that are released when we have an emotional memory that makes that memory more persistent. So we know that emotional memories are better preserved than neutral memories, and we know that a lot about the mechanism. One of the things that's going on is, I just mentioned glucocorticoids, but what, in addition to that, is the release of noradrenaline in the brain. And there's an upsurge of noradrenaline, and in particular within a brain structure called the amygdala. And we know that that interplay is really important, for example, in learning in fearful situations. And if you can stop that, you'll break that learning. And there are drugs, of course, that act against noradrenaline. Propranolol is one that clinicians will know very well. And so there have been a whole series of attempts to try and give people propranolol to try and get rid of traumatic memories. One way has been to see if it might work with those people who are at most at risk, so things like ambulance workers, people who attend emergencies. Of course, there are all sorts of ethical issues here about getting rid of a memory then. But there is another fascinating aspect, and I kind of alluded to this briefly when I talked about multiple trace theory. And this is the idea that when you bring a memory back into mind, you put it into a state that actually is labile. It's not rock solid. You've now made it vulnerable. and you can now manipulate it and change it. Or you can put in a drug like a protein, a drug that inhibits the production of proteins. And this is from animal research, not humans, I hasten to add. And you can show that that somehow can displace and remove that memory. So there are on paper ways of targeting memories and trying to take them out. The problem is translating them into ethical clinical practice.
Yeah. John, I think we probably have time for two more questions. I apologize if we don't get to your
That's
question.
fine. Sorry, I've been
Uh,
answers are too long.
No, no, not at all. How does menopause affect brain and memory function? Are there any studies going on in this field?
Yes, indeed. There have been a lot of studies looking at, in particular, estrogen and estrogen replacement therapy, as you can imagine. And there have been a lot of studies looking at the relationship of the two, um, most particularly with respect to Alzheimer's, as opposed to memory loss in aging in general. The evidence is mixed, I have to say. In other words, there isn't a clear-cut story that, for example, estrogen replacement therapy is protective, or that somehow or another menopause suddenly accelerates the processes that might lead to things like Alzheimer's disease, even though we know that the women are statistically more vulnerable to Alzheimer's disease. So there's a lot of interest in this.
Mhm.
There have been a lot of animal studies. The clinical data is people will argue both sides of this case, I'm afraid. So I wouldn't want to say definitively one way or the other, I'm afraid. The person who raised the question, they're very welcome to contact me and I can send them a whole load of studies on this.
Great, thank you, John. And John, I think we're finished with the last question then, given that we probably have quite a few A-level students on
Oh,
the
great. Good. I hope so.
thing, is what would you say the best revision technique that works for you to help retain what you're studying, the content within your memory? And this is coming from a stressed A-level student.
Okay. Well, okay. Don't be too stressed because very high arousal levels
Right.
actually make cognition worse. So try and calm down. Get your sleep levels right. Um, Alcohol is an absolute no-no, however hard that may seem. It's really not good for
Yeah.
memory at all. The best things you can do, there are three really key things. One, you need to understand what you're actually trying to remember. Understanding is the key to good memory. So don't skim over it. And you'll know if you can understand it because then you can describe it to somebody else. That's the first thing. Second thing is try and picture, imagine what it is you're trying to learn because imagery is a fantastic binder and helper of memory. So that's the second thing. And the third thing I'd say is spaced learning. Don't cram your learning, space it. So have a go at learning something. You might want to test yourself on it, then put it to one side, do something else. Come back to that thing at some later point and then try it again. So spaced learning is massively more effective than massed learning. Unless, of course, it's the night before the exam and you haven't looked at anything at all. But of course, I'm telling you, that's really bad strategy. So those are the three really key things. Understand what you're actually trying to learn. Imagine, picture it if you can. And when you revise, do it in a spaced way. And of course, don't try to do too much at one time. I mean, do give yourself breaks. Be kind to yourself as well. And, talk with friends about the material. That way you'll know that you understand it or not, as the case may be. So there are lots of other tips I could give you, but those are the really important ones.
Those are fantastic pieces of advice. And I can also reiterate that if you want to know more about this, it's all in your
Yes.
book as
The
well.
last the last section in there is 20 tips for improving your memory. And I think the 21st tip is to go back and read the book again. Bit naughty, but never mind.
Yeah, no, absolutely. John, thanks ever so much for a really fascinating
Been a
evening.
pleasure.
We've really been very fortunate to receive
Yes.
your
As I said, if there are some burning questions that people have and I haven't been able to address them, by all means, email me. I'm under the Cardiff University email account, so I'm very easy to locate.
Yeah, so those individuals perhaps whose questions we didn't get to this evening would like an answer from John, then please go ahead and
I'm
email.
happy to help, of course.
Wonderful. Hey, well, thanks again, everyone, and particularly John. We are back again next month with a talk on adolescent mental health from Dr. Rhys Bevan-Jones from Cardiff University. So that's Thursday, the 20th of March, when we hope we might see you all again. So, diolch yn fawr iawn. Thank you very much. No stop out. Good night, everyone. Bye now.